let's see if you all can get all of this. So yeah, so this is the entry point of your application. So basically, you just need the auto load composer dependencies so that you can instantiate your facade. And the facade is the entry point of the module. So it means that whatever you can do in the module, in this case is comment in this example, you can actually just call that method and just use it. This is the ready to use thing. This could be like sort of infrastructure layer code. And then the facade here, we have it in the right. We have access to the factory. These 3 lines, this is just a comment. So the IDE recognizes the return of the get factory function that you get when you extend the abstract facade. And then you have the help from the IDE. So you have the method that you have in that comment factory. So if we go to the next one, to the factory, you see that this is the place where we create the domain services. In this case, the facade is the entry point of the module. It uses the factory to create the object, and then it uses that object. So in the factory here, we have access to the config class. And here we create and we instantiate the domain services. And so the config now, if we go and check how does the config works, here we open the config in the right. The config has the ability to get the data, to get the key values from the config file. In this case, are by default are in the config directory and all the PHP files. That all of this is configurable, and we will see that I think in the next slide. So here we have these 2 files, for example, the local and the default. So from the config abstract config, from the config from your module, you have access to the config files. And here is an example of that you can actually have multiple type of config in different paths. And you can actually extend this and create your custom config files and read them however you want. In this example, this is a real integration test using multiple config files. Here you can see that in this test, we are asserting that config m, config PHP, and override, they have this 1, 3, 4. Why? Because as we are loading first the env, we have 1, 2 in the override, but then the PHP is overriding the value, and that's why we get the 4. So here is like the proof that you can have multiple and different type of files in your configuration. And then we have the latest one, the dependency provider. And here, this is basically the place where it makes sense if you look at it from the point of view from the factory. So the factory has another method which has the same name actually as in Spryker, the get provided dependency. But this basically what it does is it gives you the value that you set it in the dependency provider container. So here we are getting the facade from other module, so we can obtain it in this module, in another one, and we can inject it, the facade from another module, into one of these domain services from another module. So this is how different modules can communicate each other. So right now, let's see, this is an example of using Gacela in Fell. The project that I mentioned before. This is like the entry point of Fell. So it's basically a Symfony command application where we have different modules, and these modules has their own facade, so they can communicate to the outside world. So the facade, as I mentioned, you can actually just instantiate it and you can just use it. So the modules, they know how to get or how to do stuff. In this case, we just decide to expose the commands from the facade, and we just instantiate them in the Symfony command application. So if we go and check one example, let's take a look at the build facade. We open it here on the right, and we see that get compile command is the one that we are adding here. Let's take a look and open the build factory, because the build factory is the one that is being resolved by the build facade, right? So get factory, it gives you the build factory. And the build factory has this create compile command. So here in the create compile command from the build factory, you are creating, we are creating project compiler, whatever that means. But here we are also getting the command facade. And then here also we are getting the compiler facade. So these are facade from other modules from the same, from the same application, let's say. So this is how in the build module can communicate with the command module and the compiler module. So here we have this get provider dependency. And then here in the build dependency provider is where we are defining the compiler facade and the command facade interface. So you can actually, the locators container, it will resolve this because internally they are really singletons that they're being instantiated once and they are reused across all the modules that they are requesting different facades. So one more time, what is actually Gacela doing in all of this? Basically, Gacela is just a class resolver. It's just these 4 classes that you are extending in the structure that I just showed you. And then you get all this out of the box. So you can use the concept of facade, factory config, and dependency provider by extending this in your classes, in your modules. So now it's about, okay, but this is how to use it, but now how that this actually works inside. So this is the fun part of all of this. So we are in the abstract facade. This is when you have your facade, you are extending the abstract facade, and you have this get factory method that is returning an abstract factory. Okay, but how does the get factory knows which class need to be resolved? So by this, we go and check, by this, exactly. By this is what we are resolving. And here, the factory resolver, the color class in this case, the color class is the facade. This is important because when we call the to resolve, we have the facade, and we know the type that we want to resolve, which is the factory. This is super important because in the end, what is happening under the hood, and we are gonna go inside right now, is that it's gonna, the resolving is basically looking for the namespace of this object, and then it's looking if there is a sibling class, which is called factory. So let's go inside. The to resolve, we encapsulate the color class in class info class, nice name, and we check if we already have it in the cache. If it's not the case, we do basically 2 things. One is finding the class name that we want to create. And in case we find it, then we create that class and then we cache it. So let's focus now in the first one. How do we find the class name? So basically here we have a class resolver factory where we have different finder rules that we have here. The finder rule with module prefix and without module prefix. And so the find class name, it iterates over those rules. And the first one that is encountered and exists, then it gives you this one. So if you have, for example, the question, what if I have the both factories, one with module and one without module? Well, then it will first iterate over with module, and then it will give you that one. So here you can see how that those finder rules build class candidate works. Basically, is using the module as prefix or without. So good, now we have the resolver class. So now we have the string, which is the class name that I want to instantiate. And now it comes the fun, the a bit hardcore and totally different from what you might expect, is that we want to create a new instance. So we want to create the instance of that class. So here, this is the thing. We might have, so Gacela has an auto resolver, dependency resolver for the Gacela classes. So for the factory, you might have dependencies for your factory, for example. So you want to instantiate your factory with the dependencies that you want to resolve. Basically, here, by using reflection, you can see if the class in the constructor has dependencies, and in that case, then you want to resolve them recursively, because maybe the dependencies that you might encounter in your concrete classes, they have also dependencies. So it will auto magically work. But there is an interesting point, is when you have a dependency, which is an interface. What do you do? So this is how the resolve dependency recursively works. And we are not gonna take a look at the code, but just I want to just clarify this. There is a possibility of defining mapping interfaces. So we are not gonna look at this right now because it's too complex. Instead, we are gonna go to the example. So here in the Gacela page P that I mentioned earlier in the talk, we can define how do you want to map the interfaces when Gacela is encountering them in the factory, for example. So if you encounter an abstract class, this one, then it will give you this. But you can also define callables. So the callables are going to be called and resolved on time, on the fly, or you can define whatever abstraction you might think about. So to see at this, why all of this complexity, this came basically when we tried to implement Gacela in a Symfony application where you want to actually use the Doctrine entity manager. But how can you do this? So basically, when you bootstrap Gacela and you pass where is the entry point, you can also pass global services. This is the concept I came from, the naming, I don't know. I thought it might be good. I still think so. So you can pass key values global services that you can access them then later in the mapping interfaces. And then by so, for example, here, you can say that when there is a dependency which requires which needs this collaborator entity manager interface, I want to be resolved as the Doctrine entity manager from the kernel of Symfony. And this is super powerful, but just 1 second, here in the right, you see this in the Gacela PHP. You can, if you don't like to have this file, you can actually have it all together in the Bootstrap. This is up to you. This is equal to this one, just in case you want to have compressed in one place. So go back to the topic. Why is this interesting is, let's see an example. We have a module which is called product, and then in the factory, we are creating this product creator and product lister, for example. And for that, we need a repository and entity manager. And we might define these interfaces as dependencies from the factory. So Gacela knows that when it's encountering these interfaces, then it goes here and then it gives you this class, product repository in this case, which is a repository from Symfony. But of course, the product repository from Symfony, it might encounter a neat entity manager interface from Doctrine. So this is why when we also put here in the mapping interfaces, when we encounter this entity manager interface, then we want to have the Doctrine entity manager. And this is working like charm. So after all of this, there is one more thing I wanted to show you. It's about how crazy can we go with the flexibility of Gacela, is that actually you can have the whole concept of a module in one single file. And this shows you, this of course not, I don't recommend this in production because it's a mess, but it shows you the potential and flexibility that you can actually have by defining the whole idea bonded to one context, and it works. Everything is loaded and everything is crystal clear. I don't know. I don't know. I came with this by trying to test and doing some weird tests, and at some point I thought it might be interesting to actually build such feature. And yeah, it is really, really interesting. So basically, this shows the flexibility that you can actually use this wherever you want. So a summary from Gacela is basically just a class resolver, and it helps you to define the modular structure, and it's perfect suitable for new projects and also legacy projects, because you can just simply install it by Composer and use it wherever you want. You just need to bootstrap it when it's the entry point, and then the rest is just the namespaces. And it's all about this abstract facade, factory, config, and dependency provider concept that I already explained. The current status is we are in the version 0.11, and you can see a lot of examples in the GitHub organization. And we are looking for new challenges and see what new feature can we build. And if you have any question or any idea about how can we actually make this even better or faster, just please stay. And thanks a lot. And you can find more in the website, gacelaproject.com, and check the code in GitHub. Thank you.